Right, so in this video we're just going to put everything together and actually write full balanced equations. I'm going to assume knowledge of writing ionic formula, so if you don't know how to do that, please go back and watch the other video. So when I get to my word equation here, I've got sodium. Sodium is an element, and if it's an element, I go to my periodic table, I find the symbol and I write it down. I ask myself if it's diatomic. It's a metal, so it's not, so I just leave it as Na. Chlorine is also an element. Go to the periodic table, write down Cl. Is it diatomic? Yes, it is, so I added 2. Make sure you're not putting any charges around the elements. Then I get to sodium chloride. It's a compound. That means I need to use charges to work out the formula. Sodium's in group 1 with a +1 charge. Chlorine's in group 7 with a -1 charge. The formula is then NaCl. So what's important to notice here is that I haven't just taken the reactants and whacked them together. It was Cl2 on the left, it is not Cl2 on the right, because my charges show me that the formula of sodium chloride should be NaCl, not NaCl2. But I do have a problem now, because atoms cannot be created or destroyed. So if I have 2 chlorines on the left, I do need 2 chlorines on the right, and that's where balancing comes in. So remember, for balancing, you're going to use large numbers at the front, so I'm going to put a big 2 in front of NaCl, and by putting the 2 there, it means I'll also need a 2 here. Next one's going to be done the same. Magnesium is an element. I'm just going to write it as Mg, it's not diatomic. Bromine's an element, it's Br, it's in group 7, so it is diatomic. And then I do magnesium bromide, it's an ionic compound. Magnesium's got a +2 charge, bromine's got a -1 charge, so it works out as being MgBr2. Now in this case, it does just look like I've taken these two, put them together to get my product, but it's just a coincidence. And in this case, I don't need to balance in order to get the to have the same number of atoms on each side. Next one, magnesium's an element, oxygen's an element, magnesium oxide is a compound. Magnesium is Mg, it's not diatomic. Oxygen is O, it is diatomic. Magnesium oxide, I need to work it out, I can't just whack that together. Magnesium's in group 2 with a +2 charge, oxygen's in group 6 with a -2 charge, so my formula is going to be MgO. Again, this isn't balanced. 2 oxygens on the left, I need 2 oxygens on the right. 2 magnesiums on the right, I need 2 magnesiums on the left. Next one, lithium is an element, the symbol is Li, it's not diatomic. Oxygen is an element, the symbol is O, it is diatomic. Lithium oxide is a compound, I need to work it out. Lithium's in group 1, +1 charge, oxygen in group 6, -2 charge. The formula is Li2O. Again, this isn't balanced, I must balance it. 2 oxygens on the left, to get 2 oxygens on the right, that gives me 4 lithiums on the right, I need 4 lithiums on the left. Next one, aluminium and chlorine, aluminium element, element compound. Aluminium is Al, it's not diatomic. Chlorine is Cl, it is diatomic. Aluminium chloride, I work it out using charges. Al +3, Cl -1 gives me a formula of AlCl3. Again, this isn't balanced. 2 chlorines on the left, 3 chlorines on the right. Smallest number 2 and 3 divide into evenly is 6, so I'm going to make both of these 6 chlorines. So I need a big 3 here, 3 2s are 6, a big 2 here, 2 3s are 6. 2 aluminiums means I need 2 aluminiums, all right? So notice when I'm writing my equations that I might have charges up here to help myself work out the ionic formula, but I never have any charges in my actual equation. If you're asked for an ionic equation, you would need to include charges, but for a normal, fully balanced equation, we are not including any charges in our equation, although we might use them for rough work. Next one, aluminium. It's an element, oxygen's an element, aluminium oxide is a compound, aluminium is Al, not diatomic, oxygen is O, it is diatomic, aluminium oxide, I'm going to work it out, Al is +3, it's in group 3, oxygen's -2, it's in group 6. Cross over my charges and I get Al2O3. Again, 2 oxygens on that side, 3 on the other. I'm going to make it 6 on each side. 6 is the lowest number that 2 and 3 divide into evenly. I'm going to use a big 3 here for 6 oxygens, a big 2 here for 6 oxygens. That gives me 4 aluminiums, so I need a 4 in front of the Al. The next one is slightly different, just in its structure. I'm going element, compound, compound, element, but the process is going to be exactly the same. Chlorine is an element, formula is Cl, it is diatomic. Sodium bromide is a compound. I have to work out the formula. Sodium's in group 1 with the +1 charge. Bromine's in group 7 with the -1 charge. So the formula is NaBr. Sodium chloride, again, compound. I work it out. Sodium is +1, chlorine is -1, it's NaCl. Last up, I've got bromine. Bromine is an element and it is diatomic, Br2. To balance this, 2 chlorines on the left. To get 2 chlorines on the right, I need a big 2. That now gives me 2 sodiums on the right. To have 2 sodiums on the left, a big 2. 2 bromines on the left, 2 on the right. It is now balanced. The next one is similar. Bromine, element, lithium iodide compound, compound, element, bromine, Br, diatomic, added 2. Lithium iodide, work it out using charges. Li is plus, I is minus, the formula is Lii. Lithium bromide, similar story. Lithium is plus, bromine is minus, charges cancel, so it's LiBr. And iodine is an element and it's diatomic. To balance, just as above, I needed 2 and I needed 2. Iron and oxygen goes to iron 2 oxide. Iron is an element, oxygen is an element, iron 2 oxide is a compound. Iron is not diatomic, oxygen is diatomic. And on this side, iron 2 oxide, again that 2 in Roman numerals tells me the charge is +2. So I know iron is +2, oxygen I know is -2. Those charges cancel, the formula is just FeO. To balance, I'll need a 2 here, I'll need a 2 here. Similar with the next one, copper, element, element, compound. Copper is Cu, oxygen is O, and it's diatomic. Copper 1 oxide, that tells me it's got a +1 charge, oxygen's got -2. Then I work it out, crossing over my charges, I get Cu2O. 2 oxygens on the left, 1 oxygen on the right, I need a big 2, and that means I need a big 4. Just to note with these transition metals, the reason I'm using the Roman numerals is because the position in the periodic table does not tell me their charge. The Roman numeral tells me the number of the charge, and because they're metals, I know they will always be plus. Copper and bromine, similar, Cu and Br2 goes to, it's copper 2, so it's got a 2+ charge. That means I'm going to need 2 bromides to cancel out that charge, and I end up with the following, which is already balanced. Iron, Fe, chlorine, Cl2. So above we had iron with a 2+ charge. There was 2 in Roman numerals. Now I've got iron with a 3+ charge because there's a 3 in Roman numerals. Crossing that over, I get FeCl3. Again, 2 chlorines on the left, 3 on the right. I'm going to make it 6 on each side. So I balance it like this. The next one's a bit different because instead of having an ionic compound, I've actually got a covalent molecule. I've got water. Oxygen is O2, hydrogen is H2. They're both elements, they're both diatomic. And in water, you just need to know the formula of water is H2O. I've got 2 hydrogens on each side, but I've got 2 oxygens there and only 1 oxygen there, so I'm going to need to put a big 2. That gives me 4 hydrogens, so I'll need a big 2 there as well. Next one, similar. Element, compound, but again it's a covalent molecule that I'm making. Carbon is C, chlorine is Cl, it is diatomic. Carbon tetrachloride, tetra is 4, so it's carbon with 4 chlorines, CCl4. So it's covalent, not using charges to work it out, I'm just using the name. To balance that, I'm going to need a big 2 in front of the Cl2. Carbon and bromine, similar story, CBr2, carbon tetrabromide, CBr4, and I need a big 2. Nitrogen and oxygen. Nitrogen is an element, it's diatomic. Oxygen is an element, it's diatomic, and it's forming a compound, nitrogen dioxide. The name suggests it's nitrogen with 2 oxygens, making it NO2. 2 nitrogens on the left, I need 2 nitrogens on the right. That means I've got 4 oxygens now on each side. Next one again, I'm going from an element to a compound to a compound to an element. Lithium is Li. Hydrochloric acid, you need to know the formula of, is HCl. Lithium chloride is an ionic compound. I work it out using charges. Li plus Cl minus gives me LiCl. Hydrogen is an element. It is diatomic, so I'm going to have it 2 hydrogens on the right. That gives me 2 hydrogens on the left. Now I've got 2 chlorines on the left. I need 2 chlorines on the right. That means I'm also going to need 2 lithiums. The next one is going to be exactly the same, just with sodium instead of lithium. The one underneath, slightly different. Magnesium, element, compound, compound, element. Magnesium is Mg. Hydrochloric acid, as we said, is HCl, that you need to know. Magnesium chloride, when I work out the formula using charges, I get MgCl2, and then hydrogen is diatomic, is going to be H2. 2 chlorines on the right, I need 2 chlorines on the left. That gives me 2 H's on each side, 2 chlorines on each side, 1 magnesium on each side. Magnesium and sulfuric acid, again, element, compound, compound, element. Magnesium is just Mg. Sulfuric acid, you need to know it, H2SO4. Magnesium sulfate, I'll need to work this out using charges. Magnesium has a 2+ charge. The sulfate ion is 2-. Because they cancel, I just put them together and get MgSO4. Hydrogen is an element, hydrogen is diatomic. If I check my balancing, I've got 1 magnesium on each side, 2 hydrogens, and 1 SO4 on each side, so it's all balanced. Next one, I've got compound, 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 compound. So I've got no elements here. Starting off with lithium oxide, I'll need to work this out using charges because it's ionic. And when I do, I get Li2O. Sulfuric acid, I need to know this one, H2SO4. Lithium sulfate, again, I'll work this out using charges. I end up with Li2SO4, and water is H2O. Check my balancing, 2 lithiums on each side, 1 sulfate on each side, 2 hydrogens, and then this 1 spare oxygen, so it is already balanced. Next up, calcium hydroxide. So I've got compound, 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 compound. Calcium hydroxide, CaOH2. I'm using charges to work that out. Nitric acid, I need to know it, HNO3. Calcium nitrate, I'm going to work that out using charges. I'm going to get CaNO3, and there are 2 of them. And water, H2O. If you don't know how I'm working out these formula, please go back and watch a separate video where I go through how to work this out. To balance, I've got 1 calcium on each side, 2 nitrates there. I'm going to need 2 nitrates there. That gives me a total of 4 hydrogens there. So I'm going to need 4 hydrogens there, 2 oxygens, 2 oxygens. It's now balanced. Aluminium hydroxide, sulfuric acid. I've got compound, 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 compound. Aluminium hydroxide, AlOH3. So I'm working it out using charges. Sulfuric acid, I know is H2SO4. Aluminium sulfate, again, I'll need to work out using charges. I'm going to get Al2SO4 times 3. And I've got water, H2O. To balance, I might start with my sulfates. I've got 3 sulfates on the right. I'm going to need 3 sulfates. That's going to give me 6 hydrogens there, plus the 3 hydrogens I've got in hydroxide. That's giving me 9 hydrogens. Oh no, wait, I've got 2 aluminiums there, so I'm going to need 2 aluminiums there. And then that's giving me 2 3s are 6. 6 and 6 is 12. To have 12, I need a 6 there. So let me double check that. 6 hydrogens, 6, and that's 12. I've got 6 oxygens there and 6 there, and then my sulfates are balanced. Almost there. Ammonia, compound, compound, compound. Ammonia, just like water, you need to know it. All right. So water we know is H2O. Ammonia you need to know is NH3. Sulfuric acid, again, you need to know the formulas of your acids. H2SO4. Ammonium sulfate, we can work this out using charges. Ammonium is NH4-. Sorry, it's not. It's NH4+. Sulfate is SO4 2-. That means I need 2 ammoniums for every 1 sulfate. So I'm putting my ammonium in a bracket, and I've got the sulfate on the other side. 1 sulfate on each side, but I've got 2 ammoniums there. I'll need 2 there. And if I check my hydrogens, 2 3s are 6 and 2 is 8. 2 4s are 8. Last one I've got here, I've got compound, 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 compound. So I'm working them all out. Calcium carbonate, using my charges, is CaCO3. Nitric acid is HNO3. Calcium nitrate, using my charges, is CaNO3 times 2. Water, H2O. Carbon dioxide, CO2. 2 nitrates there. I want 2 nitrates there. 1 calcium on each side. I've got 2 hydrogens, 2 hydrogens, 3 oxygens there. 1, 2, 3 oxygens there. So that one's already balanced. Again, if you're struggling to see where I'm getting these ionic formula, go and watch the separate video where I go through them. The main message here, when you're writing a balanced symbol equation, is just to consider everything individually. Write out all of your formula, then go back and balance, and you won't go wrong.